Download this code from codegive.com, link in the description below. How to edit and compile Java jar files, a comprehensive tutorial. This tutorial will guide you through the process of editing and recompiling Java jar files. We'll cover the common scenarios, the tools you'll need, and step-by-step instructions, including code examples and explanations. Understanding jar files. A jar, Java archive, file is essentially a zip file with a .jar extension. It bundles together compiled Java class files, .class, resources, images, audio, text files, and a metadata file called meta-inf/manifest.mf, which describes the contents and purpose of the jar. Jar files are used for distributing Java applications, libraries, and components. Why edit jar files? You might need to edit a jar file for various reasons. Bug fixes. If you've identified a bug in a third-party library and have a fix, you might want to apply it by modifying the relevant class file within the jar. Feature enhancement. You might want to add or modify functionality to an existing jar file. This is generally discouraged without proper licensing or permission but can be necessary in specific situations. Configuration changes. You might need to modify configuration files or properties files embedded within the jar. Resource modification. You might need to replace images, audio, or other resources within the jar. Security patching. If you find a security vulnerability, you might need to patch the jar with the corrected class file. Important considerations before editing jars. Licensing. Before modifying a jar, carefully review its license. Many libraries have licenses that restrict modification or redistribution. Violating a license can have legal consequences. Compatibility. Modifying a jar can break compatibility with other applications or libraries that depend on it. Thorough testing is crucial. Digital signatures. If the jar is digitally signed, modifying it will invalidate the signature. This might raise security warnings or prevent the application from running correctly. You will need to re-sign the jar after modification if you want to maintain the signature. Best practices. In most cases, editing a jar should be a last resort. Consider alternatives like using a dependency management tool, Maven, Gradle. These tools allow you to override or extend library functionality without directly modifying the original jar. Creating a wrapper class. You can create a wrapper class that uses the original library but adds or modifies the desired behavior. Extending classes, if possible. If the original library's classes are designed for extension, example using inheritance, this is a much cleaner approach. Tools you'll need. 1. Java Development Kit, JDK. You'll need the JDK to compile Java code. Make sure you have the JDK installed and the javac and jar commands are available in your system's path. You can download the JDK from the Oracle website or use a distribution like OpenJDK. 2. Decompiler, optional but highly recommended. A decompiler converts compiled .class files back into human-readable Java source code, .java. This is essential if you don't have the original source code. Common decompilers include *JDGUI*, a free, standalone decompiler with a graphical interface. http://java-decompiler.github.io. *CFR*, a command line decompiler known for its accuracy. http://www.benfirth.co.uk/CFR. *Fernflower*, the decompiler used in IntelliJ IDEA. 3. Text editor or integrated development environment, IDE. You'll need a text editor or IDE to edit the decompiled Java code. Popular choices include IntelliJ IDEA *, a powerful IDE with excellent Java support. Eclipse *, another popular IDE for Java development. Visual Studio Code, VS Code, a lightweight code editor with Java extensions. Notepad++, Windows, Sublime Text, Atom * text editors suitable for editing code. 4. A zip utility *, this can be a tool to view the contents of a jar file without actually unpacking it. 7. Zip is a good one to use on Windows for this purpose. Steps to edit and recompile a jar file. Here's a detailed walkthrough of the process. 1. Extract the jar file contents ****. Using a zip utility ***. Most archive utilities, like 7-zip, WinRAR, or the built-in zip support in your operating system, can open and extract jar files. Right-click on the jar file and choose Extract All. Or a similar option. Extract the jar to a dedicated directory. Using the jar command *, you can also use the jar command from the JDK. This command will extract all the files from mylibrary.jar into the current directory. The X option means extract, and the F option specifies the file to extract. 2. Decompile the class files, if you don't have the source code. Using JDGUI open JDGUI, click File-Open, and select the .class file you want to edit. JDGUI will display the decompiled Java source code. Using CFR *. Replace CFR_0_152.jar with the actual name of the CFR jar file, myclass.class with the class you'd like to decompile, and myclasses with the output directory. Using Fernflower, IntelliJ IDEA. You can use IntelliJ IDEA's built-in decompiler by opening a .class file directly. 3. Edit the decompiled source code ****. Open the decompiled Java source code, .java, in your text editor or IDE. Make the necessary changes to the code. Important *, be careful when editing decompiled code. Decompilers aren't perfect, and the generated code might not be exactly the same as the original source code. Pay close attention to the logic and structure. Make sure the decompiled code is understandable and represents what the functionality should be. Example *. Let's say you have a jar file called mylibrary.jar containing a class comExample.myClass. The class has a method getMessage that you want to modify. 1. Extract the jar *. This creates a directory structure like com/example/ containing myClass.class. 2. Decompile myClass.class*. This creates a directory src containing com/example/ myClass.java. 3. Edit myClass.java*. Open src/com/example/ myClass.java in your editor. Let's say the original getMessage method looks like this. Modify it to return a different message. 4. Compile the modified source code ****. Use the javac command to compile the modified Java file, s. ***javac, the Java compiler. ***dbin, specifies the destination directory for the compiled class files. This creates a directory named bin, if it doesn't exist, and places the myClass.class file inside it under the correct package structure, example bin/com/example/. It's crucial to preserve the original package structure. ***src/com/example/myClass.java, the path to the Java source file. You might need to adjust this path based on where you extracted the source code. 5. Update the jar file ***. Recreate the jar. The most common and reliable approach is to recreate the entire jar file. 1. Navigate to the root directory of the extracted jar. In our example, this would be the directory containing the com directory and the meta-inf directory, if it existed in the original jar. The meta-inf directory contains the manifest.mf file, which is essential for jars. 2. Create a new jar file. ***jar, the jar command. ***c, indicates that you want to create a jar file. ***f, specifies the name of the jar file to create, mylibrary_modified.jar. ***c bin, this is very important. It changes the directory to bin before adding the files to the jar. The dot represents the current directory, which is bin in this context. This ensures that the class files are added to the jar with the correct package structure. You must use C rather than specifying the paths directly. ***c. Meta-inf, if you have any other directories to add, you can use multiple C arguments. In this case, we're assuming you want to include the meta-inf directory from the root of the extracted directory. ***. Represents the current directory that contains meta-inf. If the manifest.mf file has specific settings or entry point, make sure to copy the file and add it correctly. Alternative, updating an existing jar, more complex and often not recommended. You can attempt to update an existing jar file directly, but this can be more complex and prone to errors. **U, indicates that you want to update an existing jar file. **F, specifies the name of the jar file to update. **C bin com/example/myclass.class, change to bin and then point to path. Important notes. Make sure you are in the correct directory when executing the jar command. The relative paths depend on your current directory. Preserve the original directory structure. The package names in your Java code must match the directory structure within the jar. If the class com_example.myclass is in the com/example directory within the jar, then you must maintain that structure when recreating the jar. If the original jar file contained any other resources, images, audio, configuration files, etc., make sure to include them when recreating the jar. 6. Test the modified jar file. Thoroughly test your changes. Create a test application or use an existing application that depends on the jar file to verify that your modifications work as expected. Check for unexpected side effects. Modifying a jar can sometimes introduce unexpected issues. Test all relevant functionality to ensure that nothing is broken. Example complete. Modifying a log message. Let's say you want to modify a library, mylibrary.jar, that logs messages using system.out.println. You want to change the message that's being logged. 1. Extract *. 2. Decompile. If you don't have the source, let's assume the logging class is com_example.logger class. 3. Edit *. Assume the decompiled code in src/com/example/logger class.java looks like this. Modify it to 4. Compile *. 5. Recreate jar. Important, be in the correct directory. Assume you have meta-inf at your project root where com and src are located. 6. Test *. Create a simple test program to use the modified mylibrary_modified.jar and see if the correct message is printed. Handling manifest.mf files. The meta-inf/manifest.mf file contains metadata about the jar file. It's often important to preserve the original manifest.mf file when recreating the jar, especially if the jar has dependencies or specifies a main class. Include the meta-inf directory *. When recreating the jar using the jar command, Make sure to include the meta-inf directory. Merging manifests, advanced. If you need to add or modify entries in the manifest.mf file, you can edit the original file or create a new one and merge it with the original during the jar creation process. Be careful when merging manifests, as conflicts can occur. Example, modifying the main class attribute in manifest.mf. 1. Extract the jar, as before. This extracts the meta-inf directory containing manifest.mf. 2. Edit manifest.mf *. Open the meta-inf/manifest.mf file in your text editor. Let's say the original file looks like this. Change the main class attribute to a different class. 3. Compile and recreate jar *. If you also changed any .java files, you'll need to compile again. Then use the jar command and copy over the modified meta-inf. Advanced techniques. Using bytecode manipulation libraries, ASM, JavaSys for more complex modifications, especially when dealing with obfuscated or highly optimized code. You can use bytecode manipulation libraries like ASM or JavaSys. These libraries allow you to directly manipulate the bytecode of the .class files. This is an advanced topic that requires a deep understanding of the Java virtual machine. Using these libraries requires writing custom Java code. Aspect-oriented programming, AOP frameworks like AspectJ allow you to modify the behavior of existing classes without directly modifying their source code. This can be useful for adding logging, security checks, or other cross-cutting concerns. AOP introduces a whole new level of complexity, and the setup of the AspectJ compiler is beyond the scope of this tutorial. Important cautions. Decompilers can be inaccurate. The decompiled code might not be an exact representation of the original source code. Always carefully review and understand the decompiled code before making changes. Modifying jar files can break dependencies. If other applications or libraries depend on the jar file, your modifications might cause compatibility issues. Licensing restrictions apply. Always check the license of the jar file before modifying it. Digital signatures will be invalidated if the jar file is digitally signed. Modifying it will invalidate the signature. Testing is crucial. Thoroughly test your changes to ensure that they work as expected and don't introduce any new problems. In summary, editing and recompiling jar files can be a useful technique for fixing bugs, adding features, or making configuration changes. However, it's important to be aware of the potential risks and challenges. Always consider alternatives like using dependency management tools, creating wrapper classes, or extending existing classes before directly modifying a jar file. When modifying jar files, make sure to carefully review the license, test your changes thoroughly, and preserve the original directory structure and manifest.mf file. Using the right tools and following the steps outlined in this tutorial will help you successfully edit and recompile jar files while minimizing the risk of introducing errors or breaking compatibility. Always remember to create backups before making any changes.